Welcome everybody as you join us today. We're gonna give.
Oh no.
Uh-oh.
For the attendees just joining here, please give us a moment. We're having some technical difficulties. We'll get started. Shelly, are you back there? You kind of dropped off for a minute.
Can you hear me now?
Yeah, looks good.
I
Go
apologize. We are without internet on the campus right this moment. It just went off right before our virtual lunch and learn. So I appreciate all of you and your patience and flexibility today with us as we present to you via our phones. And so as well as data will do is how we're going to work today. For those who haven't met me yet, my name is Shelly Granager. I am Director of Alumni Relations here at CARA. Today we have Dr. Larochelle with Mechanical Engineering. I'm going to give us an update about his department. Before we start that and why we let a few more people hop on this Zoom, I just want to let you know that today it's gorgeous here in Rapid City. So if you're not in the area, you need to get back here because this is like one of those gem days where the sun's out, but it's a cool breeze. It's just perfect. We have a lot of alumni events happening across the nation, all the way from Atlanta, Georgia this month to Kansas City to, of course, those beautiful Black Hills. So get on our website, check out our events calendar, and we'd love to see you at an event. And if we're not in your area and you would like us to have one, please reach out to me anytime. So with that, I am going to do a very unfortunate, sad introduction of Dr. Larochelle because I have his beautiful bio, but it is on my email. So Dr. Larochelle is a very prestigious head of Department of Mechanical Engineering. He's done and is part of many different groups. I'm not going to do justice for you, Dr. Larochelle, but he has done some amazing things in the Mechanical Engineering Department. So with that, I give you Dr. Larochelle.
Well, that was pretty flowery, Shelly. So thank you very much, and very generous. Because of the technical difficulties, changing things up a little bit, folks. But I've got two big things that I'd like to update everybody on and share with you and brag about a little bit, and then we'll have a bunch of time for question and answers. So, well, one of the and I'll tell you what the two things are, so one is are the infrastructure and facilities and construction projects that we're doing in the CM building to continue to upgrade and modernize our facilities and our equipment. So I'd like to give an update on that. And the other big topic that I'd like to share with you today is the ME department recently won a very prestigious award from ASME International that I'd like to share with everybody today. And I'm going to start with that one. So give me a second here to let's see, 1 second. So bear with me because this is a phone talking to a laptop talking to okay. So but I'd like to talk with you and share with you a little bit about our recent award, the Don Zweep Innovation and Education Award that we received from ASME International at the end of March, just a couple of months ago. So this is the citation for the award, and I know there's a lot of words on the screen here, but I think this is kind of a good way to communicate this. So we received this award for our rigorous program on project-based product development that couples across several courses and all 4 years of our undergraduate curriculum. So this is an award we received for our mechanical engineering bachelor's degree. And we've got this product development and project-based learning happening throughout the 4 years. So it's resulted in a faculty culture change. This effort's also been recognized in a Best Paper Award at the 2020 ASEE Annual Conference. ASEE is American Society for Engineering Education, right? And so that preliminary work was reported in that paper and won the Best Paper Award. And then in 2023, we received this award for the implementation, the full implementation of this integrated project-based product development through our 4-year curriculum. So it's resulted in higher order learning, significant investments in the proposed initiatives, industry, and faculty buy-ins. And so that's the citation for the award that we received. A little bit about, what's going on and what we're doing in the curriculum and why we received this award. I'd like to talk a little bit about this National Academy of Engineering report. And so the URL is there on the screen if you want to find it, but really all you have to do is Google the title or NAE 26773, and that will get you to this NAE report, which is entitled Infusing Advanced Manufacturing into Undergraduate Engineering Education. And the National Academy of Engineers, if you're not familiar with it, is a very prestigious national academy made up of engineering thought leaders from throughout the nation, from industry and academia and government and other NGOs, right? And they're well known for very strategic, high-level thinking and strategic planning, and they provide a lot of advice and guidance to government, academia, and industry. And what they were saying is that in recent years, a lot of technologies have been developed in the United States and other countries around the world, but one of the challenges is manufacturing. And so we're developing these technologies, but we need to be able to manufacture. We need to be able to deliver, right? And people around the world are asking for increased customization. And they're also asking for decreased time between design and production, right? And even lower cost of production. And so those are some of the challenges that are facing our national economy in this global competition arena that we're in, right? And the last part of this second bullet, I'd like to point out, and where they talk about engineering education, and they say, in particular, U.S. engineering schools do not do a particularly effective job of preparing their students to work in advanced manufacturing. And we think in the ME department here at South Dakota Mines, we recognized this several years ago and have made a concerted effort to put project-based hands-on learning into the engineering, mechanical engineering curriculum so that our students are well prepared to create designs that are going to be manufactured in efficient manners with lower costs of production and with existing manufacturing technologies. And so in order to do that, we have our students doing hands-on project-based learning. And I know there's a lot of words on this slide too, but I can't help myself. I love this quote. Too few undergraduate engineering students are being exposed to or taught about the use of advanced manufacturing technologies. And of those students who do get some exposure, few are prepared to design for those technologies when they graduate. And this has a negative impact on our nation, which the report goes on to say. The result is a shortage of engineering graduates ready to contribute in this area, which in turn slows the uptake and use of advanced manufacturing technologies in the companies that are part of the defense industry. So this part of the report actually focuses on our national defense, and these are strategic issues for the defense of our nation, right? So, so when this NAE report came out last year, it really was verification and validation that we're doing the right things with the mechanical engineering program here at South Dakota Mines, right? This report went on to make recommendations in two big broad categories. And one of them was to make manufacturing an integral part of engineering education, which we do. And it went on to say engineering programs should offer experiential learning, such as project courses, capstone projects that connect to real, not prototype manufacturing. Real being you have to design something and it has to work, right? Right. Well, we do that. In our curriculum, we've developed this product development focus where we have our students learn by doing, project-based hands-on learning through all 4 years. And students are assigned to teams and they conceptualize, design, prototype, and demonstrate, right, how a product is going to solve a real-world problem and meet society's needs. And it starts in the first semester in the freshman year, as you see in the lower left picture, which is from Introduction to Mechanical Engineering. The bottom right picture is from their second course in mechanical engineering, ME 126L, taught by Dr. Aaron Lally, who's kind of there in the back left of that photo, in which the students learn not only the process for product development, but by the time they finish that second course that Dr. Lawley's taught, they've been oriented and trained on all of our production facilities and all of our labs and shops, so that as they go through the rest of their curriculum, in all of our courses, we can ask our students to design, build, prototype, test, and demonstrate, and put into practice with the theory that they've been learning, right? So this product development process that I've been talking about, right? It's more than the design process that students have been traditionally taught in engineering, and especially mechanical engineering. It's a product development process. So it's a design process within this entire process to develop a product. And a product is different than a design artifact, because a product is something that is going to be delivered to a customer is going to buy this thing, or this product is going to fail, right? So it's not just designing and building and creating a design artifact, but actually identifying a need in society or in a market, conceiving, designing, and eventually commercializing a product. And so these photographs are from that second course our ME students take, ME 126L on the bottom left, where they form their own teams, students do, and they actually go into the local community here in Rapid City, find an opportunity for a product, identify a problem that needs a solution, and then design a product for that solution. And then they take that product and go out into the community and say, does this meet your needs? Does this solve the problem, right? On the bottom right, you're seeing a series of photographs from our junior year mechatronics course, ME 351, mechatronics and measurement systems, where our students do another in-depth design project. This one has embedded software and controls within the design system. So, and again, the students look for an opportunity, design a product and prototype it, and then see if it meets that need, right? So this graphic I really like, because it shows the product development focus that we have in our 4-year curriculum all in one timeline, right? So on the left side of this is time. So time goes from left to right. So you can see on that, in the kind of in the middle of the screen, first year, second year, third year, fourth year, right? And then on the top, and the blue diamonds are all courses our students take as they go through their mechanical engineering curriculum. And these are required courses. These are courses that every ME student at South Dakota Mines takes and learns this product development process. And they learn it in depth by the time they're done. So they get introduced to it in ME 110 on the left side of this graph, Introduction to Mechanical Engineering, where they learn, the flow and, if you will, the flow chart of the product development process. They start learning how to team, how to manage teams, and they start learning about CAD software and other tools that they'll use in their projects. In their second course, in that first year, ME 126L, as I mentioned before, Dr. Lawley's Design for Manufacturing course, the students will learn CAD software, geometric dimensioning and tolerancing, GD&T. They also learn how to safely operate all the equipment that we have in the machine shop, in the wood shop, in the additive manufacturing space, in the CNC machines, and the mills and the lathes, and the arc welding, and the MIG and the TIG, and everything, so that the students can prototype their designs in that class where they do their first product development in ME 126L. And then that's followed up by ME 265 in the sophomore year, which is a required course. A lot of our students call it sophomore design, right? A lot of ME students at most universities, they have one big design experience. They call it senior design. Well, here we've got repeated design experiences, and colloquially our students refer to ME 265 as sophomore design, because it's their big sophomore design project where they do product design and development. And again, as I mentioned earlier, the students go out into the local community here, identify an opportunity for a product, and then come back, use a product development process, design and prototype a product, and then take it back to those same people and see, hey, does this work? Does this meet your needs? Does this solve the problem? In that junior year, they take the mechatronics and systems level design course, ME 351L. And that's another product design, but this one we require that they have embedded software and controls within that. So that it's going to be a mechatronics focused project, mechatronics being the marriage of mechanical systems and electronic systems and controls to have a good working product to solve the problem. And then in our capstone design, our course, our year-long senior capstone design experience, ME 477 through ME 479, fall and spring semesters of the senior year. These projects, again, are industry sponsored projects. Industry's coming to us with projects. Most years, we have more than twice as many projects from industry as we have students to run teams. So half of our potential industry sponsors and partners for capstone design, we actually have to turn away because there's such a demand for companies to have our students work on their product development problems. So we have 30 to 35 projects. Our students will express their first 3 preferred choices that they want to work on. All of our students get their first or second choice. And then we have 15 to 20 projects run every year. And again, these are industry sponsored projects. They're writing checks to support this. And we require not only the monetary support, but we require that they provide a staff engineer, at least one that's going to meet with the team every other week through the entire year, whether that's in person or Zoom. Either way is fine. And then, of course, it culminates in the design fair in the spring, where the students will demonstrate their working prototype products, right? So this product development STEM that we have through our required 4-year curriculum is what we won the Don Zweep Award for, and we're very proud, very, very proud. A little bit more about the Don Zweep Award on this slide. Don Zweep was a long-serving department head of mechanical engineering at Worcester Polytechnic Institute outside Boston, Massachusetts, colloquially referred to as WPI. It's a little bit in doubt as to when he actually stepped down as department head, but from 57 to at least 82, he was department head. He served as ASME president from 1979 to 80. And when he would, let's say, about a dozen years ago, he started working with ASME to create this award for innovation in mechanical engineering education. He was very passionate about engineering education, Don was. I had the pleasure of meeting him a couple of times. So it's the second bullet on this slide, the ASME Committee on Engineering Education and the Zweep Award Committee are the ones who select the recipients. And so we definitely want to acknowledge them. And then I also have listed on this slide and have pictures of all the faculty that teach the courses that are in this product development STEM that earned us the Don Zweep Award. So we've got going from left to right in the photographs there, Jason Ash, Cassandra Bierenkart, Aaron Lally, Micah Landy, Peter McCune, Kareem Musi, and Dan Redderth. Right? And this curriculum development was sponsored by a couple of grants that our faculty received from the Office of Naval Research and their Science and Technology Office. So we definitely want to acknowledge that financial support from them that enabled us to make these curriculum innovations and get us the Don Zweep Award. Okay. So thank you for your interest in the Mechanical Engineering Department and hearing about the Don Zweep Award. Before I dump into updates about the facilities and the infrastructure and the CM building, I thought I'd take a second now to look at the chat and see if there are some questions.
Any of the online attendees can put questions in the chat or the Q&A window there if you have any.
Okay, so any questions, folks? Or we can raise your, can they raise their hand? Yeah.
They certainly can raise their hand, or you can go ahead and write it into that Q&A, and we can get to those after you do your facilities. So that'll give them some time to get some questions in.
Sure. Okay. So, all right. So let me, again, give me a second here to get things up. All right, so let's talk about this. One of the projects going on in the CM building that I have some pictures for. So you should be seeing this nice picture of the outside of the CM building, which is now 70 in its 73rd year of existence. And I don't think anyone would argue that the outside of our building is going to win any beauty contest. The building, serves us very, very well. But we're trying to make our ME department and our CM building a more comfortable and welcoming place for all of our ME students to work and spend their time in, because they work very, very hard. So one of the things that we're doing, and we raised the focus of our Raising for Rockers fundraiser, which happened in the spring. And I've already seen names of people on this webinar that have participated in that Raising for Rockers campaign and generously donated. So for those of you that did, thank you so much. So what we were raising money for in that Raising for Rockers campaign was to do some necessary maintenance and repairs to our supersonic wind tunnel. Our supersonic wind tunnel is a unique piece of equipment that we have in the mechanical engineering department. The vast majority of mechanical engineering programs in the nation do not have a supersonic wind tunnel. And almost about half of ME programs will have a subsonic wind tunnel, but to have a supersonic wind tunnel is a real feather in our cap. Our supersonic wind tunnel was designed and built in-house. The design was done by a faculty member, Dr. Greg Buck, and actually the first PhD graduate of our department. The focus of the research was the design and analysis of the supersonic wind tunnel. And then we had a senior design team actually fabricate this this supersonic wind tunnel as their senior design project. And so they did the final detailed design and manufacturing of our supersonic wind tunnel. The way our supersonic wind tunnel works is it utilizes this big tank outside the CM building. So the supersonic wind tunnel is inside the building in there. It's actually room 125. And the supersonic wind tunnel, the way it works is there are pumps out in the floor, in the ground out here, the CM building, that evacuate this tank. And so this is a pressure vessel so that we can evacuate all the air out of this tank, and we pull a vacuum on that tank. And once that tank is evacuated, of course, there's a shutoff valve. So we evacuate that tank. That's why you see these ribs on the outside. They actually prevent the tank from imploding. And so there's a 8-inch pipe that goes from that tank to a wind tunnel, which is inside the building there, and which of course has a test section and an intake and all that, a traditional wind tunnel. So when we're ready to do an experiment, we open the valve on that 8-inch pipe, and then of course this tank sucks in all the air, which gets pulled through the wind tunnel and comes into this tank. So that's kind of in a nutshell how our supersonic wind tunnel works. So this tank has been, obviously outdoors for getting close to, well, a little over 15 years now. And so it's in need of some maintenance and repairs. And so our Raising for Rockers campaign was to take care of that maintenance and repairs so we can keep having this unique and nice piece of equipment, which is really extra valuable now since we've added the aerospace engineering minor and focus to our department. So our Raising for Rockers campaign was to do that. And I'll show you some, let's see if I can, there you go. So for those of you that have been in Rapid City in the last, I guess it's like 12 plus years or so, there's been a very popular artist that does outdoor murals, and his name is Aaron Percy. And like if you go to Firehouse, downtown on Main Street. And you see the beautiful murals painted on the old Rapid City Firehouse, which is now a restaurant and winery and a bar. Then you see some of Aaron's work, and he's got work all over downtown. So we approached Aaron to come up with a concept for some art to put on our supersonic wind tunnel tank. And so you can kind of see the outline of the tank here. And so this is his concept. So this is what Aaron will be painting on the supersonic wind tunnel after the maintenance and repairs have been done to the tank, so that the tank's in tip-top shape for the next 20 to 30 years. Then Aaron's going to come along later this summer, and he's going to paint this this artist concept, which of course includes fluids and bubbles and turbines and gears, right? And it's kind of meant to show this three-dimensional effect that it's kind of gives that faux feeling that this is the exploded interior of the actual wind tunnel tank, right? So that's what the wind tunnel tank is going to look like after Aaron does his magic on it. You also see the tank from above. You see the top of the tank from the second floor of our CM building. You see it from the third floor. And if you go to Google Maps and you look at our campus, you can see the top of the tank. So Aaron is also going to put the school name and the school colors, as I'm showing you right here, on the top of the tank. So that when you're in the building on the second or third floor and you look down in the tank, this is what you'll see on the top. And the letters are going to be big enough that you will actually be able to read them if you look at the Google Maps and get the satellite view. So that's one of the upgrades that's happening for our facilities this summer. Other upgrades that are happening in the CM building. We recently concluded a campaign to raise over $1 million for the Stensis Laboratory Endowment that supports mechanical engineering department. And we're already seeing the benefits of that campaign, right? So that campaign was successfully concluded. We've raised well over $1 million. And so the proceeds on that endowment, and by the way, if you're not familiar with endowments, an endowment is essentially an account that gets invested and saved, and then we are able to spend the earnings on those funds, right? So the principal gets invested, and we are provided quarterly the proceeds of those investments, and are able to spend those. And so the principal stays forever, so that the department will be benefiting from these funds in perpetuity, right? So the proceeds of these funds have already been, we're already spending this summer doing several upgrades. In addition to the supersonic wind tunnel maintenance and upgrade with the painting of the art on there, we also just purchased another CNC lathe that was going to go in our machine shop. We've got a very busy machine shop that supports a lot of project work, and some of our machine tools are still showing their age. And so a brand new CNC lathe is scheduled to be delivered here within 3 weeks. We recently purchased a CNC router on a 6-foot by 8-foot table for our wood shop, which supports a lot of our projects as well. And we're also doing some facilities upgrades to the infrastructure to support more spaces for our students to work on their projects. And that includes the room that the supersonic wind tunnel is in. We're totally refurbishing that lab this summer and remodeling it. And we're upgrading the facilities in there. In addition to the tank for the supersonic wind tunnel, we're upgrading some of the support systems for the supersonic wind tunnel. And we're moving the subsonic wind tunnel into that same room. And so we're really redoing our thermal fluids labs that are happening in the required ME courses. And we're making additional additions to the machine shop and the weld shop up on the second floor. We're adding new equipment and doing some refurbishments to our engine testing lab, which will enable us to not only do the engine dynamometer work that we've been doing with larger engines, gasoline and diesel engines, but will also allow us to do combustion experiments that aren't engine related in that same facility. So that would be a big upgrade for our combustion and turbine studies. And another update to our facilities is we're busy preparing a laboratory to support our new aerospace engineering minor. A couple of years ago, we added a minor in aerospace engineering that's open to all students at School of Mines. It's a very closely related field of mechanical engineering, so the vast majority of students pursuing that minor are ME students. And so we're remodeling and revising spaces in the CM building to support that aerospace engineering minor. And along with that, I'm happy to announce we have another faculty member joining us next month, Dr. Ahn, who's an aerospace engineer, and he'll be supporting us in our efforts to grow our aerospace engineering minor as well as graduate studies in aerospace engineering. So I've given you kind of a barrage of all kinds of stuff that we're doing in the CM building, and also started out by talking about the Don Zweep Award that we won for our mechanical engineering undergraduate curriculum. So those are kind of like the two big updates that I wanted to share with everybody today. And let me check and see again if we have any questions or comments about what I've been talking about or other things related to ME. I'd be happy to respond.
So Dr. Larochelle, let me go ahead and read them out so everyone can see it, hear them, and then you answer them. Does that work? Okay.
Sure.
From William, he asks, is Six Sigma still a thing? And do you qualify your students to be black belts or subject matter experts in Six Sigma?
Six Sigma. Whoa, that's bold. I don't know anybody that produces graduates that have black belts in Six Sigma black belts. Because that's a lot on top of a mechanical engineering curriculum. We do have
a green belt.
Yes, so we have a minor that's offered through industrial and systems engineering, where students can obtain their green belt, and they can do that with taking that minor, which they would use to satisfy some of their ME senior electives. So it really doesn't impede their time to graduate with their BS in mechanical engineering. And so those students that are interested in going into manufacturing and production, we encourage them to pursue that green belt, and then they usually work up toward the black belt after they've graduated and they're out in industry.
Okay. Thank you.
We also
Aaron,
I'll just add one more thing. We also have a senior elective that Dr. Lally developed a couple of years ago and now is taught a couple of times, where that course is focused on design for product quality, which focuses heavily on manufacturing quality, and is heavily related, of course, to Six Sigma and green belts and black belts. Okay.
Sorry about that. Thank you.
No worries.
Aaron says, congratulations on the award. And what key changes, if any, would you anticipate to the curriculum, your curriculum, over the next 5 to 10 years? Like, for example, do you have a process to continue to evaluate if you're meeting both current and future industry needs?
Oh, that's a fantastic question. Yeah, call us out, make sure we're still relevant. Absolutely. So here's what we do. So every year at the beginning of the academic year, we have a department meeting that's just focused on looking at the undergraduate curriculum and with the faculty. And we get together and we talk it out and make sure, and we look it over and we make sure that we're doing the right things in our minds. Every other year, we take our curriculum to our external advisory board. Our external advisory board is made up of alums and industry representatives. And we take our ME curriculum, both at not only at the BS level, but also at the MS and PhD levels, to that external advisory board and seek their input as to what we should be doing. I think a great example of this is the addition of the aerospace engineering minor. The faculty talked about it and thought, well, maybe we should be doing a little bit more to formalize the aerospace engineering education that we're providing to our students so that they can have something on their transcript. And then we took that conversation to our external advisory board and they said, yes, 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 yes. And so that what we did is we formed a team of faculty and advisory board members that then reached out to their aerospace industry and got their input as to what we should be doing in that aerospace engineering minor, right? So that's kind of how we work it in order to make sure that we're staying current and up to date. And we're actually not trying to stay current and up to date. We want to remain on the cutting edge, right? So, you know, like what happened with this REAP award, right? We start working on stuff 4 or 5 years ago, and then we get this REAP award. And then last year, this NAE report comes out saying, well, maybe you engineering programs should think about doing this, right? Well, we've already been working on that for 3 or 4 years. So hopefully our processes will allow us to continue to stay that way and stay on the cutting edge of mechanical engineering education.
Thank you. And then I have a question from the chat. It says, first of all, from Dave saying, very interesting and great work. Do you have labs that utilize or teach 3D printing technology?
Oh yeah, absolutely. So as we've remodeled and refurbished our facilities in the building, we've kind of got an animal slash nature theme going on for all these facilities. So I'm just going to rattle off the names of the facilities. We have this big space on the second floor where teams could just get on a butcher top workbench and start working on their projects, you know, assemble them together and put them together. We call that the zoo, because there's all kinds of different stuff going on in the zoo at all times, different, just like when you go to a zoo and there's all kinds of different animals, right? So there's that zoo facility. So it's a long answer to your question, but so we have another facility that we call the aquarium, all right? And it's called the aquarium. The students named it because you walk the hallway on the second floor of the CM building, and it's got a big bay window. And when students work in there, they feel like they're inside an aquarium, and the tours are coming by, and everybody's coming by, kind of looking inside at them. And so inside the aquarium is where we have our additive manufacturing and 3D printing. So we have a wide assortment, well over a dozen, probably close to 20 different 3D printers, different materials, printers that do support material. We also staff this room with our manufacturing mentors through the academic year. Our mentors are advanced, experienced students that have great knowledge in this facility, and they help our students use the aquarium throughout the year. So students can be working on a project and they have a CAD drawing and they come to the aquarium and say, I'd like to 3D print a prototype. Well, then they get taught, well, okay, what are the steps, right? Okay, where's your CAD model? I need an STL file. Then I need to slice, and I need to use some slicer software to slice it. What material do you want to print it out of? All that, which printer do you want to use? So they get provided a lot of advice and guidance to use this technology, which is rapidly evolving. So that's why we provide that kind of support. The aquarium is open 24/7, unlocked to all students at all times of day. The aquarium, we allow our students not only work on class projects and research projects, but like all of our shop and labs, we allow our students to work on anything they want as long as they do the engineering and do the work. So they can't just come in with a hunk of metal and start making chips. But if they do the design work, they have a process plan, they have a bill of materials, they can show they did the engineering and the design work, we will let them use all of our facilities free of charge, and we will support them because we see how valuable of a learning experience that is. So I know that's a long answer to your short question. The short answer is yes, we utilize and teach 3D printing technology.
Excellent. I don't have a question. I have a comment. Someone just said that the painting that you're going to have done on your wind tunnel looks like it's exploded.
Yes.
I think they found that pretty cool. But yeah,
I hope
if
so.
you right. And they're doing some amazing things over in the mechanical engineering. As I am fortunate enough to be on campus and can walk through Surbeck and different places, I've been able to run into some of their sophomore design shows. So these students are not just designing this and then showing their professors. they're taking these, their designs out to a fair here on campus where people get to walk up and they have to explain what they did to like me, a layperson. And so they get a little bit more of that technical communication just through that too. So I think that's a great project. And it's also a lot of fun to be that customer that they're trying to meet the need for, to go back and forth and to see that process. So for you alumni out there that are thinking of all your great ideas of projects you'd like to see happen, feel free to share those. Dr. Larochelle, would you have someone in mind that you would like them to share them with, or how do they reach out to you to get a project on your list?
Me, that's
Okay.
make it simple. Just reach out to me, and then I'll connect you with if someone else if I need to.
Excellent. And we will be setting up a follow-up email after this, either Friday or Monday, with contact information, the link to share this Zoom with others, and also Dr. Larochelle's contact, so that you will have it right there to send those design ideas into. And it is, I have to say, a lot of fun to be a part of and see how proud those students are when they get that final design done. So it's a lot of fun. Thank you, Dr. Larochelle, for your time and sharing with us with what you're doing on campus, and for all that. I know our companies come back year after year because of the hands-on experience our students are getting, and mechanical engineering is a big part of that. So I really appreciate that. I want to thank all of our alumni and friends that joined us today on this Zoom. We'll be doing more, so keep checking your emails. We'll be sending out some more to you. And if you have questions anytime through the year, or you come on campus, please stop by and see us. I know Dr. Larochelle would love to see you too if you're coming on campus. So stop by to the mechanical engineering department and see them. Even in the summertime, on weekdays, our buildings are open. So you can just come on campus and see what we're up to. We'd love to say hi. Again, I just want to thank everyone for their time, especially Dr. Larochelle. And I will be posting a link to his bio, because he does and has done and continues to do some amazing things in the field of mechanical engineering and mechanisms and machine science. So I would like to share and give kudos to him on that. With that, Dr. Larochelle, do you have anything final to say? Otherwise, I'd like to thank everybody.
Just the last thing I'd like to say is just thanks again for everybody for your interest in staying connected with mechanical engineering at South Dakota Mines. Thank you for your promotion of the school and the department and the program. Thank you for your financial support and your word of mouth, because the way we grow our enrollment and recruit the great and bright minds of the future is quite often the best recruiting tool are you folks. So thank you so much for spreading the word about South Dakota Mines and mechanical engineering at South Dakota Mines.
That's right. And I will be sharing next year, be reading your e-news that we send out monthly. I'll be sharing next year the dates and times of those mechanical engineering fairs with you, so that if you are here in Rapid and would like to go and question these students and see all the amazing things they're doing, like the drink mixer that I saw, I believe it was a sophomore design group make, which I thought was pretty fun. So I will be sharing that with you so you can be part of that fun too. And again, I want to thank everyone for your day. I hope you enjoy your summer, and I hope to see you on campus soon. Thank you so much. Bye-bye.